as you guys already saw in the video, that periodic data, periodic functions is nothing but any situation that we can get it out of. It's repeated. So you will see exactly same shape over the graph over and over and over again, right? So periodic means it has to be the exact repetition, right? It has to be exact repetition over a certain amount of time, and then it has time period has to be same, and then the way the position change or anything in the context moves along the exactly same row over that period of time or period or whatever, right? Okay, so let's see what kind of situation that we can consider as periodic data, right? Okay, so 8.1, exploring periodic data. Okay, so let's start with some explanation and definition like explanation here. Periodic motion is motion repeated in equal intervals of time. Okay, then what could be examples of this periodic data? So examples. Cardiograms. You know, in the hospital, and you know, you see the vital signs there, right? And as you can see, the machine that measures someone's heartbeat, the cardiograms, and then it literally shows the graph. It goes up and down, up and down, up and down, right? So I guess it indicates the, you know, blood pressure moment by moment. So realistically, nobody's heartbeat could be mechanically exact time. You know, there is some, you know, if you're human, and there is a tiny little difference every bit, but generally it makes the graph and then up and down, up and down, up and down, right? As the time goes by, right? So heartbeats every 0.75 seconds, then it's gonna be go up and down, or every 0.75 second. Then what else? Spinning wheels. So spinning wheels, and then if you focus on a certain point on that circle shape, then if you observe that certain point starts at certain position, and then it goes one circular motion and hits the original position again, and it completes revolution every certain period of time, unless there is speed change or something like that. And if you are constant speed, then we expect one circular motion will take exactly same time over and over and over again, right? Then it's not the specific example, but we can see a lot of observation from the weather is cyclic too, right? So weather, for example, it's just, you know, temperature, and rain amount, sunshine. Did I say sunshine? Oh, by the way, so there's a really popular Netflix series from Korea. It's titled Mr. Sunshine. I recommend it. It's a very, very good story. It's like, it's kind of sad at the end, but yeah, over the spring break, you know, if you guys just need some TV series that you want to just kind of like binge watching and just forget everything, and I strongly recommend to watch that. Mr. Sunshine, okay? And sunshine, and what else? Yeah, it's so like every cycle of 12 months. And astronomy, every night you can just observe how the constellation move, right? And definitely sound, right? Or light waves. What else? Oh, like, and it's not really cyclic motion, but we can have some oscillating motion. What's oscillating? It's not circulating, completing the revolution kind of thing, but oscillating means either vertically or horizontally. It keeps moving like back and forth. That's what is defined as oscillating motion. So for example, like bungee jump. Have you ever done a bungee jumping? Who's a brave one? I'm super afraid of heights. Oh my God, like I would not even be able to just climb up to the point that you jump with your bungee. Oh my God, that's crazy. It's so insane to me. Okay, bungee jump, and so, but this one is a little bit different, but it's still periodic data, and we call it so it could cover, you know, the bungee jump, the going up and down, or bouncing balls, or, you know, a lot of machines that has the pistol motion, and then it just keeps the part of the machine like going up and down, right? Then you can observe how this one full motion happens over what period of time, then you can make the data as the periodic function, right? Okay. Is there anything else that you think of? Okay, so I guess it's just pretty much that. Okay, then, so then if we make this data into a rule, the function, then pretty much we will see the graph goes like this. So for example, we will have, for example, if we have some like height changing. It's just highest point to the lowest point, and then it keeps the same range over time, then the situation can be grabbed like this. So let's say this is how high it goes. So let's define this one is maximum height, right? And let's say this is how low it gets. So then let's define this height as the minimum it can go down. Then if this one constantly remains the same height, then we can get the mid position between maximum and minimum, right? So then let's get the mid position in the middle between maximum and minimum, and then we call it, this is midline, okay? Then what could be the shape of this periodic motion? So let's imagine, so an object starts from in the middle, right? Then it's 0, so starting, let's say this is the beginning point, and then it could be on the ground. Then let's see, this is a 0 level, and then it starts from here, right? Then as time goes this way, let's say this object goes up and then hit the maximum point, and then it goes down, and then it passes the 0 level, and then it hits the minimum below, and then bounce off, and then it goes up towards the maximum again, and then it goes down. So then as indicating the time passes that direction, it will look like this. So then now from starting point, beginning point, and coming back to the same position that it started, then this is one repetition of that motion. Then it has to be repeatedly exactly the same. So then now we measure this time period that it took to complete the revolution, then it's gonna have exactly same there. So then this is another time period that takes, right? So then in this case, we will name the part in here. Then we assume this is just a certain part that we are focusing on observing. Then we assume this will be continuous, the same repetition all the way to the left. And then this will continue, keeping the same circular motion or any motion, exactly same repetition all the way to the right. And the way that we indicate it is the arrow in both ends, right? So then now we can consider one repetition, and then we will make rule. Then we call it, if you consider this is starting point, and then it goes up and down, and then this is the one repetition will repeat every time of the period, the time period, then we can call this one as one period. So from here to there, and then this is one period. But it depends, right? You can also start from the top position, and then it goes along, and then it ends at another top position. So then that's also one period too. Here to there, right? So then this could be one period too. But as you see, this blue highlighted period and purple highlighted period doesn't matter. Doesn't matter what part of that periodic data, that the period itself as the time period should be the same because it's all the same repetition. So then why don't we just pick in the middle of here, and then it goes until in the middle of, yeah, that's totally fine too. But the thing is, since this one is exactly repetition the same way, so then as long as you just do, whenever you focus on to get the period, and then it's gonna end up at the same period. And then now that's how we define the period right there. Then also there's another one that we have to know. So we can see the midline in the middle of maximum and minimum. Then we measure how far either maximum or minimum are from that midline. Then we measure that, and then we call it as amplitude. So here, this is amplitude. And then also here is also amplitude. So then it could be positive or negative if we consider the midline happens to be 0 level, right? So usually the amplitude is absolute value. Amplitude is only the simple pure distance, whether it's going up or down from the midline. We just simply measure the distance. So in order to get rid of the direction-wise positive and negative, and we usually notate it as the absolute value down there, okay? Then what else? Yeah, that's pretty much it. Then here, further later, we will talk about phase shift and midline changes, but that's nothing but shifting. So imagine that you take a certain period or even certain part of this periodic data graphs, and then you shift it to the right or to the left, or you can also move it up or down. So then it's technically translation, the horizontal shift or vertical shift there, but we call it phase shift instead of horizontal shift, right? And we call it midline change instead of just actually the vertical shift. But I don't really care that phase shift or horizontal shift or something like that because it's just the same meaning. Okay, then I think that's pretty much the parts here. Then here's another better graphics for you guys to see. So this is x-axis here. Then x-axis definitely indicates the time, and then 0 and 1 to maybe it's second. And they define the period from the lowest point to another lowest point. And if we consider this one was originally started at the 0 second, and then we can see there's horizontal shift to the left a little bit, because it could be just 0 here, right? It was horizontally shifted to the left by a little bit, right? And also midline is not actually on the x-axis or t-axis, the time axis. So definitely we see it was vertically shifted up, and still amplitude is from the midline to the maximum, or you can consider measuring the distance from the midline to the minimum as well, as long as you get the absolute value, right? Okay, so then algebraically you can find midline position is just in the middle of maximum and minimum. Then you can see minimum value plus maximum value and then divide 2. Then it's gonna be whatever the midline. And the midline is a horizontal line, right? So it's gonna be, you know, y equals whatever the value that you get for midline, right? Then also amplitude can be calculated algebraically. Is you take maximum and then you subtract the midline value, then that could give you the amplitude here, right? Or you can just have midline minus minimum and then get the absolute value. That's also work, right? So then it's gonna be absolute value midline no, actually, I guess it depends. What if the midline is not minus, right? So then for definition, let's keep only this one there. Okay, midline is that way, amplitude is that way. And period is just, it depends how you define the starting point and ending point, right? Okay, then let's do one example here. So as we already saw, as the example of the periodic data, then I picked this problem here. This is about the Ferris wheel. So as it is indicated by this diagram, and the center of the wheel is C, and this point P is where the people get in the Ferris wheel, then that's 20 meters above. Oh, the center is 20 meters above. So this is 20 meters here. And it rotates once every 30 seconds. So it's 32 seconds. Then if you start from this point P, and then it will go all the way, and then it hits the original P position over 32. Wait, is it too fast? Oh my God, I would not be able to get on this Ferris wheel. It seems really, really fast to me. Okay, but so this is also 20 meters here. So it's just same height. And then this is 20 meters too, right? And then if the ride begins at point P, P is here, and when time t equals 0 second, and then, oh, there's some omitting parts. So then what we are supposed to draw. So draw a graph that gives the passenger's height in h, in meters, above the ground as the function of t. The t indicates the time passes, right? So then, now, okay, then I think this direction is missing how high is here. Oh no, so actually the radius is 18, right? So then this is 18, then this must be 2, right? Oh yeah, then makes sense. Then that makes sense. So then technically, if we just the wheel, so the wheel itself in the center, and then this is 18, then that means from the ground, this is 2, right? And then this is 18, this is 18, and then this is 18, and then this is center, right? So that's why this is from here to there is 20, right? Okay, then this is a starting point. And it's gonna be on the graph. So if we draw the graph, and the horizontal axis will indicate the time. Then the vertical axis will indicate the height, right? Then where should we put the midline position then? Midline position should be in the middle. Then that midline is how high then? This will be 20 there, right? This will be 20. Then as time goes by, and it's gonna go up, 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 and then hit the maximum. So maximum will be how high? From 20 meters, it goes 18 more meters to hit the highest, the maximum. So it's gonna be what? The maximum will be 38, right? And the minimum will be then how high? Minimum will be, this is minimum. So then going down, down, down past the midline here, and then it hit the minimum is 2. So then the graph should, as time goes by, it's gonna hit maximum, and then past the midline, and then it's gonna hit minimum, and then this must be the 1 revolution. Then how long does it take 1 revolution? 32 seconds here. So then this is gonna be in the middle, so 16. And this is 8. And then middle of middle, the second half will be 24, right? So that's where it hits the minimum. Then if it keeps the same speed, then it's gonna go up and down, and once again, and then this is one period. So the period is 32 seconds. And then this is amplitude. So amplitude should be what? 18. Okay. So where is the midline? Midline is y is 20. Okay. That's how we can depict the situation that includes periodic data as the graph. Okay, how is it now? Was it helpful? Did it help for you guys to have a little bit better understanding? I hope so. Okay, so now it's about the time. It's